So in this second session, we will start explaining different integrations, not only KNX, we have already done it in the first one, but also very important protocols like BACnet or Modbus, for example. With KNX, there are the three big ones in the building automation systems. In Europe and the rest of the world, I think, Modbus maybe is the less used or the most old, the older of the three, but it's also being used in a lot of projects also. And it's important to understand what are the advantages of integrating directly with native drivers all these three devices, all these three different systems. Because in a normal project, sometimes we need to use physical gateways to integrate KNX with Modbus, for example. And this is sometimes expensive. And this is also limiting our possibilities to even to get the project sometimes because of the cost of the gateways. With the BMS, we will save a lot of that money because we will have a direct integration. Okay. So let's go to BACnet. Okay. I will first, as we did for the KNX, I will show you the tables that are empty, as you can see, the BACnet devices, the BACnet IP devices, okay, even BACnet IP gateways, objects. This is the data points for BACnet. The name of the BACnet data points are the objects, also empty, okay, devices and objects. This is the two tables that we will handle with BACnet. We also have a possibility to define properties because each BACnet object has a lot of properties that we can also extract from the object. It's also possibility to extract a specific property. It's empty, okay, from the beginning. So what I'm going to do is to discover the BACnet devices in my network. This is a difference between or from KNX because KNX has not this discovery tool. Okay, this is a difference, an advantage of BACnet in our opinion, but KNX has many more advantages also, a difference from BACnet. But important thing is to have the possibility to get both protocols in the same tool. To discover BACnet, I will stop the BMS. And this is necessary because my BMS is also, it can be also considered a BACnet device because we are BACnet clients and we are going to act as a BACnet client to get information from BACnet devices. But we can also act as a BACnet server. And this is very important. As a BACnet client, what we have to do is to get information from the BACnet field devices. So first, we have to do is start Explorer. This option was in gray color before because it was not active, because the server was also activated. So this is the reason why we have to stop the BMS. So starting the Explorer, we get a message. This message is in the other screen. This message says that my local host IP 127.0.0.1 is not valid. Okay, no problem. This is because we haven't defined the device that is going to explore the BACnet, which is the IP address of this network card, we can say. Okay, let's say yes, we want to find a different one. It's appearing here. And if you have different IP addresses, you can select the one that you have in the same network of the devices and just select OK, and you will get this screen. Okay, what happens? Two devices appears. Okay, I will show you first this. This is the one you have. Let me change the camera because you're looking a guy that is not interesting for you, but I will show you the other camera. and I was also hiding the device itself. This is the device, the BACnet device. Okay, this device is the BACnet gateway, and has show you the picture before, 52 input, 36 outputs, for example. So you can see all these objects here in the screen. On the screen, you can see the binary inputs, okay, binary outputs, but these outputs are not the right ones, because it's necessary here to create a specific output blocks. Well, it's a question of the PLC, because these outputs are not possible to control through BACnet, so it's not interesting to import it. We can save and select this here, or we can do it, of course, after importing if you want. Okay, so we will do this way. And this is the BACnet device, okay? One device with some inputs, outputs, analog inputs, etc. And there is a second device that is, I call it the BACnet converter home, because I have some elements that can be exported to BACnet. It's just a second example we can use. Some things from my house. So you can see we have a metering general consumption, for example, from the KNX power supply, the temperature, some other different temperatures coming from KNX, but this device is exporting to BACnet, and we can see here is a BACnet device. So I have it configured and we have different temperatures, and this is also possible to import. So we have two devices. The first is just some typical items, and the other is from a PLC with inputs, outputs. It's typical also. So what we have to do is just export. Okay. Select here and say yes. We want to overwrite all these files, because it's like overwriting. And that's it. We have to exit, and then we have to start our server to see the result. And then we will have KNX and BACnet. In the gateways, you will see first in the left, top left window, gateways. And then in the item tree, in my XIO driver, XIO branch for the native drivers, we will see also this BACnet integration. So some seconds for this restarting and creating of the items. Now is reading. Okay, that's it. And we have what we had before, and now plus a BACnet, two BACnet devices in my XIO. I have my previous KNX, okay, I'm not interested now, but my BACnet with my device with some items, so temperature, for example, my laundry, or my dining room, or whatever, all the metering value, for example, kilowatts per hour. That is useful because we can use it for whatever other things. It's interesting. If we need it, we have something from my house now in BACnet, for example. This is just an example, but the device we are going to take a look on it and use it for the examples is this. We have my inputs 52 from 0 to 51 and my outputs to control. So this is the outputs. This is a different between input and output because input is just a signal. So I can show you, for example, if I force an input, you will see, for example, in binary input 0, 1, 2, and 3, the value will change from false to true. I will do it manually. So you can see that the inputs are changing, and I can also force the outputs from here. Write item, for example, and I write value 1, and there is a small change in one LED there, but it's difficult to see from the screen, but it's possible just to change this. Okay, so you are changing the status of these outputs and from BACnet. Okay, so I would turn them off again, and it was really easy to do this because it was just discovering of that elements that are mapped into BACnet. So now, and this is very interesting, we have BACnet and we have KNX, and we mentioned this is a tool for integration. One of the most interesting things we can do is the integration, and there is a lot of possibilities now to integrate KNX and BACnet, BACnet to KNX, KNX to BACnet. One of these is using a simple link. This is called a virtual link. It's very easy to do this, and we can do it different ways. Imagine, for example, that I want to link the binary input number 0, for example. Imagine this is just an example, and send the values that appears here to one KNX item. So to make this more spectacular, we have the broadcast, and we have a light central off lights, for example. So if this item changed from false to true, it will write this value here and vice versa. How to do this link? We can do this just dragging and dropping. So we are creating, it is possible to be more complex. It's called a task. So it can be complex with scripting or whatever. No. It's very simple. I just want a virtual link from the source. This is the source, the BACnet input 0, to the destination, that is the KNX. So, and why can we do this? Because both are items of the same tree, the BMS item tree. Different branches, yes. Different protocols, yes, on evidence. BACnet and KNX are nothing to see one with the other, but they are brothers now. These items are brothers, so we can interact and we can relate, we can link. And this link can also, for example, be done from the next input, for example, with, imagine, with the move of the shutters. So this means with a virtual link that if we send a 1, the shutters will go down, and if I send 0 with this item, it will go up, for example. So where are these items? Because it is a screen that is shown and disappear, but there is a table here in the menu extensions where you can see my virtual link definitions. And this has a live text before. Live means that when you do these changes, it's automatically working. You don't need, definitely, you don't need to restart again the BMS platform. And this is interesting because you're not going to lose a lot of, or invest, better say, invest time restarting the server. Why is not necessary to restart in this case? Because these changes are not affecting the item tree. You are not creating new items. When you create a new item defining something, you need for sure to restart the BMS. And this is a process that takes some seconds, not so much, but it takes seconds, and it's disturbing your normal process in the building. So I can say save, but you can see here both items. We can do also manually. You can insert a new definition, of course, and you can select from your, for example, I can do also from BACnet to BACnet. Imagine that the third input, the input number 2 is the third one. I want to activate one of the outputs, for example, this one. And why don't we do with others? I mean, we can also take this. Imagine that with the input 2, I can copy this. And we can activate not only the first, but also the second, the third, and the fourth. Why not? So you can do a sort of multicast communication in BACnet. And if you don't have that possibility, for example, you can do it. It's like a scene, a sort of a scene, very easy done. If something changed with that input, you will have 4 lights, 4 outputs in BACnet activated with the third, with the input number 2, this is the third one. The first and the second are affecting KNX lights and shutters. So let's take a look if it's work. I will show you directly. I just press save. I am not forced, as you can see, to restart the BMS, and I just can test it. I am going to activate the input number 0, and so you will see all the lights on. And when I release the cable, I have some cable for doing this test, you will see the lights off. I will do with the second, with the input number 1, that is the second, and you will hear the shutters going up and down when I press and release, and the third is for the BACnet object. So you will see now with an example. So first, second, third, so this is working fine. Okay. So this is a virtual link. Very interesting, but in this example, it's a bit dangerous. So I will not delete it, but just make them to sleep. Very easy. Convert to comment. Okay. So you have the example at the end, but now they're not going to disturb us anymore if something strange happens. So what do we have after this BACnet importing? Let me show you the tables from BACnet. I can hide all these things. BACnet device. Okay, you have 2 devices automatically configured. This is the number of the device internal, the number of the other device, net IDs, which network is directly in our network or no, and the IP, well, the MAC or the link layer address is the IP of the device plus the port. The port BAC 0 in hexadecimal is the same port normally for BACnet IP. And nothing more to do with the devices, just to remember the name of or the number of the device. I could copy this for something I will show you. Object definitions, and this is specifically for the first one. We just need the number of the device. Device ID is the number, and the object ID that is specific for the device or whatever is analog value or whatever with an object name. It's an analog value. Something is not writable, but they have a write priority. Is not necessary in this case, but with a polling interval because it is a subscription for these objects necessary as a subscription, and the different configurations that you may need to do. And for the other device, you have the rest of the items, some inputs that has not write priority. There is an array of different possibilities for the write priority. And for the outputs, we have this. For by default, the latest priority is 15. That means the 16th priority. And if you have some devices, this is a BACnet specific thing. If you need to test different position in the write to write an item, because maybe you write and it's not working, you can check it. You can change this, for example, to a different priority number 9 or even 8. that is put a 7. And also you can also do this, and this is very interesting to check. You can put all this. If the last number is not working, you can, for example, test from the 8 to the 15 and just save this. And this is going to affect my BMS, but my item tree, so I need to restart, and you will see that we will have an item tree, and for this specific first output, you will have different possibilities to test the right position in the right array, the priority for writing. And this is a BACnet specific thing for the writing objects. And this is possible to do very easy here for testing, because sometimes the manufacturer for the BACnet IP device decided to put the priority for the priority. So you have to test, because it's not working fine at the beginning, but this is because of this reason. But you can test it very easy for one object, for example, and then you can get as a result this. In BACnet, for example, I will show you the second is as usual for the last priority number 15, but look at the first one. You have all the possibilities to check with the right item for the priority number 7, 8, whatever. And this is just a small, a very easy change you need to do in the BACnet object definitions table. I will put them back again to 15 and in the next. I will save, but no, I don't want to change it. Save it, but it's not going to see the result until the next restart. So this is BACnet integration. So we have very interesting my device, my object, and my properties. So let's open again the tables, because the property is very interesting. Sometimes we need to select a property, a specific. For example, the reliability is typical. I need to know the reliability of one specific object. So it's just to do this. Okay, it's not appearing, it's not wasting a lot of information on and disturbing a lot in your item tree, because it's very simple. You just have your elements with no several things behind that. The priorities are hidden, but if you need it, it's just selecting the object and define the device of this. For example, let me say this. The device name is this name. The device name. Okay, no, the device ID. Sorry. The device name is the filter. Name is my device. The object name. Imagine that we want for this. Again, for this first output, this is the name of the object, okay? And the reliability. If you want another one, copy paste or do it in Excel. Excel is a really nice state text, for example, and the polling interval, for example, and the access rights. If you want to, if a property is readable, unwritable, or whatever. And this is a property definition that you can also take information from the objects and show it. The best interesting thing is to show it to you. Saving this, what is happening is that behind this object, we will have a metadata and other items, sub-items, exactly in the same position of this object. So it's very interesting. I will hide the camera because now it's not interesting to show you the boards. It's more interesting to have a big screen with all this. Okay, so my item tree again, and I'm showing you my BACnet first. So what do we have? Well, the reliability. The other thing is not a property of this object, The reliability appears here for this specific object. So it's very interesting also. Okay, let's continue with other protocol, because we will use BACnet. We will use, as I mentioned before, from this channel for the second card, digital output number 2, channel 1, 2, 3, 4, 5, 6, 8, 7, 8, and the third card 1, 2, 3, 4, 5, 6, 7, 8. We will use these objects for the hotel rooms, for the do not disturb makeup room. I will use it. The question is that the name of the object is a bit more complex. You know, the item ID of this object is a bit mess. It's complicated. So we will see in the next session, in the evening for many of you. Some of you are very far away from here. So in the last session of today, we will see the alias concept. So you will see how we can harmonize and we can reorganize and rename and structure our items independently of the origin of that in a proper way. So it will be very, very interesting, because one of the objectives of the training is to make you think big for the projects. Give you a bold thinking for what is a building automation project with integration and all these things, and giving you the tools to make it easy, to do it faster and in a professional way. So this is one of the biggest objectives for this. So in BACnet, the last thing to show you is the mapping definition, but this is not for today, because mapping definitions is when we want to have my objects in BACnet, any kind of objects mapped in BACnet to act as a BACnet server, not as a BACnet client. We are now a BACnet client, and we are integrating devices from BACnet. This is the BMS acting as a BACnet client, okay? But sometimes we have a specific SCADA or visualization that is a BACnet client, because the customer needs to integrate KNX or DALI or whatever, and Fidelio or whatever, in a BACnet specific visualization. And this BACnet client is from a third-party vendor, a different manufacturer, and they need everything in BACnet. This is not a problem for us. We can do it, but this will be explained in next sessions. I think it's in session number 5 or 6. Don't remember. It's no, it's oh no, in the next one. Yes. Yes, in the next one, in the last version, but not now. Now we have to continue with Modbus. Okay, so let's go to Modbus. I will close this and I will show you how to integrate Modbus elements. Okay, so Modbus. We have also a specific menu in the menu bar for Modbus. Device and data points. So it's more or less the same always. Modbus devices, Modbus data points are tables that are empty now. It's something text explaining something here. Okay, so we can take a look here to this. So what you have to do in this case is this: put a name, in the case of the device, sorry, first. Put a name, an IP address, the port, the slave ID of the device, and a description. Normally with this is enough. Something extra is the maximum parallel commands, the request timeouts, and so on. But normally with the default values that you have here in the first column, it will be enough. So you need to know the device name, because this name will be also put here for the data points. And you need to know the IP address, of course, of the Modbus TCP device. If it's a gateway, it's the same IP for all the slaves and the same port, but with different slave IDs. the best way to show you this is with an example. So I will give you also these tables, but we have in Excel some examples already done. So we have to do is just press the button from Excel and take it from my session to resources that we will give you after everyday sessions. Okay, so we have sessions to Excel files. Okay, so we have from Modbus device definitions. I think we are in the device definitions. Yes, I have some examples that are coming from my house. Okay, this is, I will not restart now. This is an example from my house. It's just an example. We will activate only some of these, not all. Okay, because some is not interesting. Well, SAI is in Spanish UPS, uninterruptible power supply. Okay, I have a UPS. I have my main switch, sort of line. It's the main switch with an analyzer and so. And I have my practical board, my electrical boards have all the protections, all the electrical protections have information about the status and the possible failures and all these things. And they are monitoring with a device that is called SmartLink from Schneider Electric, in this case, with some slaves. So some of the slaves are Wi-Fi and Wi-Fi device, wireless devices that are giving me information about the energy consumption and other information, power, current, voltage, and so for specific important elements. So I thought I had the right file here, but it's not the right one, but it's not a problem because I'm just deleting the ones that I don't want to use. Okay. And the description is the main switch. And an energy analyzer. And this is for our aerotherm. The word is always the same. And the electrical vehicle charger, for example. I have monitor these elements. And this is the definition for the devices. If you take a look, the IP is the same for this, and it was for the SmartLink. The same IP is from the SmartLink IP, but the number of the slave is different. So it's the same port, with the same IP, but the number of the slave is different because these are slaves of the gateway or Modbus TCP gateway. And this is the 3 different devices. In this case, there is a lot of other configuration that are not necessary to change. And in the data point definitions, we will take from Excel also. And I will have to take a look. Okay, there is a lot of things that is not interesting. So I will delete it. I will change this because it's a lot of information that is not interesting and it's not in English. And I changed it yesterday, but I didn't get the right files, I guess. I'm afraid. Okay. In this case, interesting for us is this counter, and the rest is not interesting. This one, for example. And this is not here defined because I have a lot of things in my home BMS, but we're monitoring everything, all the protections, all the differential switch, and all these things. But I wanted to show you just small things. And this is in English, so it's okay. And it's the last one. Okay, well, tension, voltage, intensity, current, potence, power, okay, counter, energy, power factor. It's similar like in English, but in the at the end, the final version, you will get this in English. Okay, no problem. But I will just restart. So we have devices, and we respect the name of the devices here. So this is very important. Okay, the name of the devices has to be respected. And then the Modbus protocol is just to define if it's a discrete input, it's like a binary input. If it's a coil, it's like a binary output. If it's an input register, like an analog input, or a holding register. A holding register is a register that you can read and write, so it's equivalent as an analog output, for example. It's not exactly the same thing, but it's how Modbus is distinguishing the different kind of data points in Modbus that they call registers. In BACnet, remember, they were called objects. In KNX, we call them addresses, group addresses or physical addresses or individual addresses, group addresses, individual addresses, KNX, objects in BACnet, and registers in Modbus. Every single protocol has a different way to call their data points. But at the end, it's very similar because you have devices and you have data points. And this is the philosophy to integrate everything in the BMS. The big difference between Modbus, for example, and BACnet, or even with KNX, is that this integration is vendor specific. So this means that you have to do it manually. It's not possible to discover, for example, registers automatically in Modbus. But what you can have is a manual from the manufacturer, so you can take the manual and do this integration very easy and fast. Well, if you have done 1 or 2 million times this, it will be much faster than the first, but it will be very easy. It shouldn't have to be complicated. And if you have some questions or whatever, you can ask, but it's not complicated. Sometimes the only thing that is maybe complicated is to understand that the register, the address, for example, in this case, the address, maybe the manufacturer is telling you a different thing than the real. I mean, sometimes they are indicating you the value of the register in their mapping. So you may see in the documentation, for example, for Schneider, the register number 3000, but you have to put the real address is one less. This is the only difference sometimes, but this is a specific case, not a frequent. And the most typical thing you may change is about this configuration, word swap and double word swap. This is because, and I will point it out, the word swap and the double word swap is because the registers in Modbus are 2 byte. Sometimes the info is not in the least weight byte. It's in the most in the byte with the biggest weight. So we have to swap the bytes to get the information in the biggest, in the first, not in the last byte. So the word swap is for this, and the double word swap is also the same when you have registers with not 2 bytes, with 4 bytes. This is also typical because some of the registers, and it's very frequent, need 32 bits to codificate, to code the values, to have a bigger for example, a resolution, a bigger range. So you need registers, double registers with 4 bytes. So the double word swap is the same, is to swap the position of the bytes because of the information is positioned in the bytes with highest weight, we can say. And this is by default true. This configuration are both true. I'm telling you this because in some occasions you have this by default for the whole devices, because this is the device table in true, but the manufacturer says in some specific registers that you have to define them in false. Some, the double war, the word swap, you can see here that is by default is in the device configuration, but here you can change it specifically for each of these registers. Sometimes you have to put again in false, and the double word swap if it is the double register at 32 bits register again, but some not. Some you have to put again or put in true or do nothing. So you have to play with this. This is the only tricky thing in Modbus. Play with this and realize what is the correct configuration in order to see the right information of these devices. Because if you don't do this, you may have strange information. And this is a very single question. It's just to change this for the whole device or only for specific items. As you can see, in the rest of the elements, it's by default. But in some of these first device elements, it's this way. So this is the only thing to consider normally in Modbus, and many times is nothing to do. So you don't have to do anything. And then, as you can see, we are getting information from my devices here. So it's very interesting because it's not complicated to get information from Modbus. Well, when you have done it 2 or 3 million times, I repeat. But if it's the second, the third time, you are handling this very good, no problem. The only tricky thing is, okay, to do the correct configuration, so you see, okay, this is correct, and of course, take a good look on the manual of the manufacturer, because sometimes, for example, the voltage is 100 times multiply, for example. So it's 22905 is not a voltage, it's a high voltage, but this is an integer. So instead of giving you a float or real with decimals, they give you an integer multiplying the resolution 100 times, 1,000 times. For example, the power factor here is 642, so it's 1,000 times, because the power factor is between 0 and 1. Or for example, the energy, for example, is 100,000 times the value. So if you want to know, you have to count 1, 2, 3, 4, 5 decimals. So it's 27,000 kilowatts per hour. We have been living here for 3 years almost, so it's not so much for a house. And we are going to install the photovoltaic. This is the next step. In a few weeks, we will have photovoltaic, so it will be fantastic to have a less carbon footprint. That is the most important reason for this. So we have integrated our Modbus elements, so it's fantastic, with some consideration about the factor. And we will see in the trending, for example, definitions, we can consider this. And also in the logics, if we need items with the real values, we can also create a scripting. We will have some logics. We will do a lot of things that is possible to convert this to a real item with a real value, not just the raw value that is coming from Modbus. We don't have to stand with this information. We can get the real information if necessary. So it's very interesting. Okay, so my Modbus devices are also integrated. Fantastic. We can use it all over the training, and that's all. Of course, I have it already prepared before, but it takes some time to do this work, and of course we have no time to invest for this, but it's not complicated. I promise that if you take some time and you read the manual of the manufacturer, it's really not complicated to do this. And you can integrate. Now you have 3 protocols: KNX, BACnet, and Modbus. So it's really interesting. But we have more to show you. For example, SNMP. SNMP is very interesting. SNMP means Simple Network Management Protocol. It's a protocol that has some years, but it's also very interesting for data centers, for IT infrastructures. For example, at home, I have a switch, MikroTik, for example. I have some NAS. I have a Modbus camera, for example, and many information from these elements is possible to get it. Also reading the manuals. So I can also take from Excel these files. So let me go SNMP device, for example. Okay. I have 3 devices, the MikroTik switch, the NAS, hard disk, and the Modbus. And then also data points from Excel is the polling definition. This is called the polling definition. And I have here I will restart after. Again, this is not in English. I'm not sure why, but I did it yesterday, and I have it in the backup of the BMS. It's in English, but I will give you the right one at the end, no problem. But you can just see that this is also giving us a lot of information from the switch, from the NAS, and from the Modbus camera in the door entrance. So just saving all, restarting, and you will see this SNMP. SNMP is, again, like Modbus, has to be done manually. You have to put the object ID, OID, in principle manually. I hope in the near future we will have a tool that can do discovering of all these elements, but this is vendor specific again, so it's not as simple as we may think. But this, again, just take a look on the manual, and you will have this information. So you can get information from the IT infrastructure, for example. And this is very interesting. In my case, I can know if any cable is disconnected, for example, from my router. So I can go to SNMP, I go to my MikroTik switch, and I see, for example, this cable is disconnected. And okay, it's the Raspberry Pi VPN because I have disconnected by myself. Oh, this one is disconnected. This is the LAN in the dining room. Okay, I know this because it's still pending to install whatever. And again, this is not present or whatever. So it's interesting to have this information. For example, for a switch like the switch at your premises, you can also get information about temperatures, for example, temperature of one device. So you can trigger it. It's an item. So you will see tomorrow how to handle an alarm, for example. And this is, if this temperature is higher, for example, than 50 degrees, you can trigger an alarm. Take a look on the NAS because you have a lot of temperature in this device, and it's, or whatever. For example, you have a system status with a value, a number. If it's 2 is a failure, the power status can be failure, the fan status or CPU fan status or whatever. So it's very interesting. Or even the gateway, the device itself can be monitored. So everything can be monitored in the BMS. It's very interesting. And the Modbus camera, for example, again, the same. We can have, for example, the lux illumination or the camera temperature, for example. So you can, again, if it's daylight and this is not a right value, maybe somebody's occulting the camera or whatever. So you can also trigger alarms, wherever. So it's very interesting to use this SNMP, and it's a native driver again in our BMS platform. So it's just define the devices, define the version code. It's a port typically 161. It can be, the community string is also editable in the devices. We can choose any kind of version, 1, 2, and 3. The third version is possible with login specific permissions to access to the devices. So it's really complex also protocol, but we don't have a lot of time to explain this. But as I will explain afterwards, in the knowledge base is also possible. to take a look on these examples. Okay, so again, a new protocol, KNX, BACnet, Modbus, and SNMP. We can go ahead and go to the HTTP. This item, this menu is one of my favorites, and it's being more and more used because we can also interact with APIs. HTTP is really powerful driver for us. We have these options to communicate with HTTP or with TCP or UDP in a specific branch of the item tree. We will explain this in the next session. But HTTP is very, very interesting because it can give you the possibility to interact with elements like, for example, web pages that can give you the information in a XML format or a JSON format, for example. So it's not easy to explain because when we have a good example, it's much more easy to show, but it's really powerful. So I will again open the tables that you can see they are empty. Data points is the polling definitions, or polling or interacting definition, because in the HTTP we can not only get information, we can also put and post information. We can do these kind of things. The resource definition is to extract the information for the specific JSON web pages. I will show you how to do this, but with the example direct, so you will understand what I am doing. The example in the training is a web page for the weather forecast. It's an open weather map. It's a company from Latvia in Europe. But we are using this web page because they are offering you a free account. So if you are not doing a lot of pollings, you can get this. So we can get from Excel this information, and I will tell you a small thing. Okay, and the resource again from Excel. Resource. Okay. So let me show you something. This is looks to be a bit complex, but I will try to explain. The web page, I will copy this URL. I will open a web browser and I will try to open the web page. Okay, this is the web page, open weather map. So you can search your city. Imagine that we want, well, this is automatically, it's not Sarajevo, it's near Sarajevo, it's Siero, but it's more or less like this. You have a forecast, etc. But the most interesting thing is the API. So here we can have a call API, for example, one call API. So it is giving you a minute forecast, the hourly forecast, the daily forecast, and historical data, and so. You can create a subscription, so you can have a subscription, even free, so you can get the API key. And this is what you need. API key is a token, so you need to create an account and get a token. A token is a code that you need for the string. This code, this is a token. This is my private token, so it's not going to share it. Or if somebody sharing is using it, I will change it. But what you get from this API is the information in JSON. So you can see here all the elements that you get from this. Okay, so you get this sunrise, for example, in a specific format, the temperature, the feeling the temperature feels like, the pressure, the humidity, the dew point temperature, the ultraviolet incidence, the clouds in percentage, the visibility in meters, the wind speed and the wind degree from the north. So it's almost south, the wind, okay? And the wind sensation and some descriptions, clouds, few clouds, an icon or whatever. This is, and every minute, for example, precipitation every minute. So it's a lot, it's a huge information you can get from here. So hourly, again, hourly, daily, or whatever. If you are interested in some of this information, you can just get it. So this is what the web page is showing you, but a lot, okay, a lot of information. But I am interested in using my my BMS to get this information in items. And this is the most interesting thing. An item for me is a really power tool to use, because if it's an item, it doesn't mind if it's coming from BACnet or from KNX or from the web. It's an item, and I can use it in visualization, and I can use it in logics, and I can combine, and I can link with another protocols, whatever. So how to create items getting information from the web? Just the answer is using the HTTP driver, the HTTP definitions. So imagine that I want, for example, the temperature. Temperature is a name that I give. I can also give this path to organize weather at my home. This will be a folder inside the HTTP driver, and home will be a folder inside weather folder. The data type has to take a look on the different possibilities. It's a float because it's a real value. You can check or you can test, of course, float. Then it's the polling URL with my token, okay? And this is a result of reading the documentation from the website. So you need to create this URL and use exactly the same URL for all the definitions. This is just one single query, A polling interval, this is also important. If you have a free account, not to abuse with a polling interval. This is every 900,000 milliseconds. It means 900 seconds. This means every 15 minutes, okay? Every 15 minutes. And here, the polling resource is the important thing. I call this second level. Why? Because this information in the web, temperature, let's go up again. The temperature, this value is what I want to extract is inside current values and inside a second level that is called temp. So this means second level. For example, the clouds is also second level. It's in current and clouds, for example. But for example, there are the latitude, for example, it's in a first level. You know what I mean. It's in the structure, it's main levels and secondary levels and third levels in some cases. So if you take a look on your structure, you just need to put this here. So there will be some of these elements in second, some in third levels, in first levels or whatever. And then if you want, for example, extract exactly the temperature, this was in current category and inside the temp secondary category. So this is the definition for this element. The second level is defined in resource definition. So second level is a JSON, because it could be XML, JSON, or URL decode, or a text, or whatever. It's really huge, the fantastic driver. And this is specific for JSON, $dot between keys 0 dot between keys 1. So this is specific format. We give you the example so you can play with this. But don't use this token because this token is private. Create your own one. Thank you. And, and this is a get information. But as you can see, we can use this also as a post put. So this by default is get, or by default is post, but we're using the URL, so it's a get at the end. But you can use this not only for get, also for post and put. And this is the example. See, if we take a look on the, we have to save all, and we restart the server, we will see how the BMS is asking this website, how the BMS is taking the information from that website. And this is really interesting. Some seconds to wait for the restarting. But at the end, and before it starts again, that is doing now, remember the power of the BMS is going to be more clear. Every minute we see different protocols that we can also integrate. So take a look here. We are in connection with 4 different protocols natively, without any gateways between KNX and BACnet, without any gateways between KNX and Modbus, because the devices are Modbus TCP. We don't need any gateway, or even if they are Modbus RTU, we just need a Modbus TCP gateway that is cheap, and we get it in the BMS. We don't need expensive KNX to Modbus gateways that is giving you 2 problems. First is the economical problem, the money that it costs. And the second is that if you have a Modbus gateway to KNX, you will put all the traffic from Modbus into the KNX field. And this is not good because you are adding traffic that is not good for your project. In this case, the BMS is solving you all these issues in one shot. So let's take a look. HTTP driver, weather, home. Look, the folders that I mentioned before in the data point definitions, we have weather, home forecast. Okay, so you could see here that I have something, for example, the sunrise and the sunset, that we have to process to get this specific data in real date and time. The temperature, and feels like these are items now. So I can use it in the visualization. I can use it in my logics. I can trigger an alarm because of this value. I have the humidity for free. I don't need a weather station for this case. Of course, the wind speed is better to measure at home, because if you trust on this, maybe you will have a problem with your awnings or with your shutters. Take care with this. But for the temperature, for the external temperature, for the humidity, the radiation, or many information that maybe if it's raining or not, or all these things, is not possible. About the forecast, we only have not only have this information, we have the forecast for the 3, for 6 hours, for 9 hours, for 12 hours. So at midnight, we will have 9 degrees at midnight. Oh, not bad. Tomorrow at the same time, it will be 14. 2 days after tomorrow, it will be a bit better. This is winter now in Spain, so remember we are in winter time, but not bad. Temperature, but this clear sky or whatever, that you have all this information for free, because we are using an account that is giving me a token, a permission to read all this information for free. For free means about the web page, but not about the items, because we have now in my license more than 1,000 items that I am using. But it's good because I have a lot of protocols, and we are saving money only in items, not in gateways. Okay, so we have a lot of savings in this case. HTTP. I will now show you NETx automation web page, because it's important at this point for you to understand that there is a lot of information in the web page, and specifically in the knowledge base. The knowledge base right link is this. I'm telling this because this is really new. Stefan can confirm that the web page has only a few days, some weeks, and the latest version of the BMS is a question of some days older, and you didn't realize to change this link. So when you press this and you get this information, you are not going to the right link. So this will change in the next version, of course, of the BMS, but this is not a bug. It's a problem that the web page is really, really new. So this item, this link for that is coming from the BMS knowledge base from netexautomation.com, this is not exactly the right one. So don't use this. Just go to the web page and that's it. So it's not a problem. You will have this corrected in the next version. So this is the right one. So I repeat, in the web page, go to the menu, support, knowledge base. And this is really, really, really nice tool for you, because you will see here a lot of examples, and you can just write a filter tutorial, integrate with content from HTTP servers, for example. You have here a tutorial where you can you have the explain of how it works, how you get the driver, because the driver is not by default installed. I have it here. It explained the XML, the JSON, the URL, the text and code, an example, and whatever. So this is really interesting for you to understand how it's working, and not only use the same example with the weather web page, because you can do a lot of things with this. Okay, so this is really, really interesting, the knowledge base, not only for this driver, but for many other occasions. We will go back here and take a look on the knowledge base. So, and to finish this second session, we have seen a lot of, we can see there is a lot of protocols, but we need one more, OPC. As a client, we can also get information from different OPC servers, okay? An OPC server is commonly used when you don't have a native driver for specific protocols. For example, for fire alarm systems, is typical, or old automation systems, you may need to convert this to OPC. It's like I'm Spanish, my mother tongue is Spanish. Stefan is Austrian, so his mother tongue is German, and we talk each other in English because I don't speak German and he don't speak Spanish. But our OPC, we can say, is like the same, is the English. So OPC is the universal language, we can say, for automation. So if you don't have a native driver in KNX and BACnet or whatever, is OPC is a solution. But it's not the best solution, because OPC is not the perfect, we can say. It has a lot of some tricky things for the configuration, and some issues with the communication sometimes. And there is two different options. I will show you OPC DA. This is the classic, we can say. Classic is an optimistic word. It's an old version, but it's the most commonly used now. But is interesting to see. So to integrate OPC, we do as for BACnet, we stop the BMS because we are going to discover. Okay. It happens the same as for BACnet, but in this case we cannot avoid it. The BMS is also not only a OPC client, it's also always OPC server, always. So if I do a discovering, I will discover myself as an OPC. I will show you as an example, and then I will show you another OPC server, real OPC server. So for doing so, we have to go to the cluster menu. This is the first time I show you this menu. Cluster, okay, we have server definitions and item definitions. It's typical. We have some devices, in this case servers, and items behind. They are empty, as you can see. So I close this, and I close this. But I have a good, let me close also this from HTTP. Cluster Start Explorer. Okay, this is very simple because I only have one button to press. So press this button and then we can select the type of servers we can read is direct VNet, and this is not time for this because it will be explained, I think, in the 9th session, the cluster configuration for other BMS. Now it's OPC DA in this case. So this is the menu to integrate OPC DA. So I have to put a name. Let me say my own OPC server test. It's just to show you that we have BMS core server. Let me refresh the OPC list because you can see that we are still present here. We have BMS core server. It is my own server, myself. If I just select it and I press it, I have new icons, but it's very simple because this pencil is to edit this. Okay, no, I'm not interested. This red cross is to delete it, so I'm not interested. So the next to press is this one. And this is starting exploring, a discovering of the OPC objects you may have, for example. So should open a new window with all the OPC elements that are in that OPC server that it's casualty, exactly the same server that we are using. So this is a useless example just to show you that is the process to discover the items is taking a lot of it's taking time because it's a lot of items in my server. It's a huge amount of items. Okay, this is my own item tree. So yeah, you can see. I can just take one element, for example, from, let's say, from BACnet. The general consumption, this one, for example. I just select, oh, sorry, my mistake. I didn't select it. Again, now it takes only seconds. I will select it. BACnet. Okay. This one, I need to select it. I say, okay, I have only one element. Okay, this is one way to do it. I have another possibility because I was surfing the web and I discover a OPC server simulator. Fantastic. It's a tool. It's just an example. It's a tool that is a simple OPC server and it has some items here. You can add elements, no problem. You can add a row, for example. Put here test session 2 string. Okay, value hello world. Okay, and that's it. It's a number of elements to test. It's just an OPC server, but we should discover this. So we should, if I explore and select the OPC data access, we should have it here. Let me refresh the OPC list. And yes, we have it here. So I will say this is a OPC test. And then I can explore, and you can see I have, this is the server and this is the items that appear. So I will select and include all, and I have 14 elements. Okay, so that's all. I say, okay, this is the discovering for this one. And then I just have to start my server and my colleagues will need to give me a new license in less than 1 month. It's a reminder from my BMS. So it's starting again. And let's check. Now we have here my, it's not in XIO, yes, it's in cluster, okay? OPC, okay, we have to restart again. We need to, in this case, we have to restart the server because it has to be created again. So it's just a few seconds to show this in the item tree, and we finish this session. But remember, it's very interesting because we have seen how to integrate BACnet, Modbus, SNMP for IT infrastructure, HTTP, and you can take a look in the web page, and also OPC servers, OPC DA, but also OPC UA. It's also possible to check OPC UA servers in a not complex way. So it's very interesting. So let's check OPC. We have 2 servers, for example. My own OPC server is only 1 item, but it's working fine because it's getting information from my energy item, and the OPC is this. And there is a hello world somewhere. No, it's not. It's not present, the hello world. But we can try to have 2 times this. Maybe this is the problem. I have 2. Okay. And I do I did the change. Well, it doesn't mind. We can maybe change the value, byte value 100, for example. Update it, and this value should change here in a few seconds because there is a polling. Well, anyway, it is. It is the way that we can integrate OPC. Doesn't mind the operating, the way it operates in this case, because the most interesting thing is that you can check, you can get the information from this OPC. I will close it, and we get this as an example. So a lot of things extra, more than KNX. We have a lot of things, a lot of items, and the most important thing is that I can use anything for my own interest, because all these elements are brothers in the item tree. So we can combine it in the visualization and so on and so on. So it's very interesting. So that's all for now. I will show the camera and say goodbye. So see you in 1 hour and a half. Yes, I'm here. See you in 1 hour and a half, and thank you for your attention. So we'll share with you all the videos and all these documents. Okay, thank you. Bye.